Hello everyone, so we're just going to do an update on the big storm that's going to be coming through the eastern seaboard this weekend. Please excuse the sound of the dryer in the background. I apologize. I'm sure you guys can still hear me though over that. But this is the satellite picture right now. So this here is the first disturbance that came through earlier today. The center of low pressure is all the way up here across southern Canada and northeast of the Great Lakes. So all of this cloud cover is associated with that. That's going to be moving off or up soon, up and out. This area of clouds and moisture is associated with your next disturbance that's coming through. That's currently, your trough is out here over the Midwest in Nebraska, Kansas, Oklahoma, extending back into Texas. Your main trough is back in here. And then you have an initial wave further down south that's going to combine with that trough, and we'll look at that in a minute on the forecast models. If you come to your water vapor imagery here, this is really cool. Take a look at this. So again, this is all the moisture that's moving off associated with your low that's up here over southern Canada. And then all of this moisture is associated with your next disturbance. Now, look at this push of dry air coming in behind all of this moisture here. So what this is doing, this push of dry air, it's a collision between air masses here. So this cold front that's draped across the area here with the trough coming through, the short wave. You have low-level winds pushing moisture out of the Gulf onto the land here. And it's rising above this cold, dry air here. And, you're getting some pretty intense thunderstorms down in Louisiana, Mississippi, and Arkansas, and even into western Tennessee. There's some pretty intense severe weather right now. Unfortunately, I don't have time to cover severe weather tonight. I will try to do a video on that tomorrow to cover tomorrow's severe weather threat. But, there's some pretty intense storms. There's a tornado watch down in these areas until 3 a.m., so watch it if you're down there. But anyway, this disturbance is going to be really key because it's going to move to the north and east over the next 36 to 48 hours. It's going to be bringing drenching rains to portions of the northeast here, into central, southern New England and portions of the mid-Atlantic, and then portions of the Great Lakes as well. And then up north, it's going to be bringing a big snowstorm. Right? So, a lot of stuff going on here. I've done severe weather the past 2 nights, so now I'm going to give you my forecast for the main storm. Alright, so if we look at our, this is from the European model. Okay, so this is from earlier today. This is your first wave that's coming through, your short wave, and then up here is your disturbance that's going to combine with that. So now if we go to the next run here, so here is that initial wave that I showed you. It's right here now. It's over Mississippi, and then you have a trough coming in from the west. So this is going to be what creates your storm, this piece of energy here. It was back here, now it's over here. Okay, this is going to create your wave of low pressure, and actually it already has. And then this short wave coming through here is going to guide this either to the east or up. How many times have we seen that this winter? Well, it's not winter anymore. But how many times have we seen that? Like, a lot. So, now the thing is, this trough doesn't become negative very quickly on any of the models. However, it does combine with the initial wave here to the point where the upper level low is going to try to close off, and when it does that, it's going to try to come to the north and east. And most of the models show that it does. However, the GFS and the Canadian models are a little bit further south. The European is the farthest north. And most of the snowfall forecasts for northern New England are further north than mine is. I went a little bit further south because there's going to be an area of high pressure over southern Canada. I'm worried that's going to suppress the low to the south. And I'm worried if that happens, that cold air would make it further south and you get more snow. Now, I could be wrong. Most of the weather stations, other than me, are trending further north with the snow, but I have it a little bit further south. Just in case, Okay, so here comes your trough, your short wave. That's going to guide this to the east for a little bit, then it's going to combine. It's going to close off and come to the northeast, and then it'll start to become negatively tilted. So let's go to our next run of the European model. Alright, here we are. Here's your initial wave. Okay, see, this is actually starting to become negatively tilted now. Here's your trough. It's a neutral tilt. Okay, this is at 1 p.m. on Saturday afternoon. So this is going to start to come together now, and the low is going to start to close off. Skipping ahead, let's come here. This is late Saturday night. Actually, before we do this, we should go in order. So this is where we were, and this is where we're going. So your initial wave is up here now. Your trough is actually slightly negative now, according to the European model. So it starts to shift to the northeast, and it's adding to it. This short wave is adding to the initial wave of low pressure, and watch what's going to start to happen. It's going to start to close off. See that coming together? You can see the vorticity is starting to circle around a little bit. Your low pressure is actually up here still, but I believe this is your upper low. I believe over here you have your surface low. Again, if I'm correct, I still don't understand the difference between looking at an upper low and a surface low on a map, so I'm still gonna have to, learn that. But you can see how the vorticity is starting to wrap around here. That means your upper low is trying to close off. We are at Saturday night right now, so let's go to Sunday morning. All right, so on Sunday morning, again, you can see your vort max is now shifting around here. Now here's the thing. So by Sunday morning, your area of low pressure is up in the Delmarva here, and you have this huge area of vorticity. So now on the northeastern side, where I'm pointing right now with my mouse here, this entire area is going to be an area of intense upward motion down in here as well, across the Delmarva, and then out over the ocean. This is going to be strong areas of upward motion. So you're going to get a lot of lift, a lot of rising vertical motion off the ground. So you have more, and then when you have a low up here that's trying to close off, the flow takes moisture back in from the south and shoots it back to the northwest. So what does that mean? You get heavy rain across southern central New England, and then back up to the north you get heavy snow, and there's also going to be some wintry weather, like some ice in certain areas that are going to be close to freezing, but not cold enough for all snow. Okay, so I want to show you the difference though in the models with regards to the vorticity map. Okay. Alright, so we were on hour 48. Alright, here we are. So here's the GFS. Now, notice how the GFS, your center of low pressure for the European is right up in here. And for the GFS, it's further to the south. It's down in here. The GFS has the energy being a little less potent. However, it's also further south, and you can see that up on the top here, this vorticity max this vort max is starting to become a little bit negatively tilted as well. So that's shifting the wave up to the northeast. The GFS has this going further to the east. Okay, and you can see I actually see more of a closing off signature with the GFS. So I think that kind of confines the heavy precipitation down further to the south as well. That's what the GFS is showing. This is I think this is actually your initial wave of low pressure down in here. Look where the European has it, all the way up here. You see that? You see this branch here? I think that's actually your initial wave of low pressure. Look how far south the GFS has it, all the way down here. See that? Alright, so GFS, European, GFS. European, GFS. European, GFS. Okay? Now let's go to the next one. Alright, so you could clearly see the vorticity, the wind energy is clearly starting to wrap around and come northeast. So again, northeastern side of this is during the day on Sunday. Strong areas of upward motion are now extending across central New England. And again, take a look. See this? It's just a little bit farther to the south, and it's actually out to sea. It's got the GFS takes it along a more easterly track than northerly track, so that's the difference. Okay. Also, if you ask me, this disturbance looks a little bit more negatively tilted on the top. You can kind of see that, right? Negatively tilted now. Look at the GFS. There's no negative tilt at all. It's more neutral. So what this tells me is that this low comes a little bit farther north, so heavier precipitation a little bit farther north with the European, a little bit farther south with the GFS. Okay? Now, here we go. Your strong vorticity, your vortmax is starting to come into the northern, into Long Island, New York City there. The GFS keeps it all to the south. You see that? So that's the difference here. So this was a little bit more negatively tilted, so you can kind of see the isobars here are shifting towards the negative side. And then the GFS, they are not really, they're more neutral. So the GFS keeps this farther south. And the Canadian model, which just for the sake of time I'm not going to show, but the Canadian model also keeps it further to the south as well. And then the other thing I want you to notice is, again, as this disturbance comes over the ocean, the upper level low is going to strengthen, and so again, that flow around it is going to bring heavier moisture back across southern portions of New England and the portion of the Mid-Atlantic there. Okay, so that your upper low strengthens, you get intense moisture coming off the Atlantic. That's why you have heavier precipitation further east, because as it nears the ocean, it has a better source of moisture, and thus much heavier precipitation back in here, and then heavy snow to the north. I'm telling you, it's going to be a big snowstorm for extreme northern New England. Alright, so we've looked at both of the models here. You can see the European is a lot more intense with the wind energy here. Okay, you see that? European, GFS, European, GFS. Okay, so you can see how it's just a lot more potent. And then the Canadian model, what it does is it brings this further east like the GFS does, and then it starts to become negatively tilted further east and pulls that further up. And it slams the eastern seaboard here with heavy precipitation, so it makes it more of a coastal storm. And the other models aren't showing that, so I'm going to take that into consideration with my maps that I made here. And I did take it into consideration, but mainly I'm not going to go with coastal storm right now. I think it'll come a little bit farther north. However, what I'm worried about is there is going to be a strong area of high pressure up in here. I'm afraid that that's going to suppress it further south. So I think we might start to see a southward trend with the models, like as you can see in the GFS and the Canadian. The European is still farther to the north, but we'll have to see if that comes further south as well. So I tried to base my snowfall map and my rainfall map on a combination of those different solutions. Okay, so in the next video I will show you those maps.